The 25-foot tap rule, as detailed in the National Electrical Code, NEC, permits tapping into a main feeder circuit under specific conditions. The primary concern revolves around ensuring the tap conductors are adequately sized and protected to prevent overheating and potential hazards. To properly understand the situation, we must consider the main overcurrent protection, tap conductor ampacity, and grounding conductor requirements. In this scenario, a 200 amp 240 volt main is tapped using 6/3 NMB cable with a number 10 ground wire, feeding a 30 amp 2-pole enclosed breaker. The tap length is 25 feet. The 25-foot tap rule mandates that the tap conductors have an ampacity of at least 1/3 of the overcurrent protection of the main feeder. In this case, the main is protected by a 200 amp breaker, therefore the tap conductors must be rated for a minimum of 66.67 amps. Since it's impractical to have a 66.67 amp rated wire, one must go up to the next standard size that exceeds it. Now let's analyze the specific wiring used. The 6/3 NMB cable contains number 6 American wire gauge AUG copper conductors. The ampacity of number 6 AWG copper conductors depends on the temperature rating of the conductor insulation. NMB cable, also known as non-metallic sheath cable, typically has a temperature rating of 60 degrees Celsius or 140 degrees Fahrenheit, as well as 75 degrees Celsius or 167 degrees Fahrenheit and 90 degrees Celsius or 194 degrees Fahrenheit. For NMB cable, you are required to use the 60 degrees Celsius column unless specifically permitted otherwise in the NEC. It is critical to understand which ampacity to use in this case, and that the ampacity must be 1/3 of the main overcurrent protection, meaning the conductors must have an ampacity of greater than 66.67 amps. Now let's move to the grounding conductor. The installation used a number 10 AWG grounding conductor. The NEC requires the equipment grounding conductor EG to be sized according to NEC Table 250.122, based on the rating of the overcurrent device protecting the circuit. In this case, the overcurrent device for the tap is the 30 amp breaker. NEC Table 250.122 indicates that for a 30 amp overcurrent device, a number 10 AWG copper grounding conductor is sufficient. However, the original concern mentioned that the grounding conductor should also be sized at 1/3 the ampacity of the main conductors. This is a misunderstanding of the tap rule requirements. The grounding conductor is sized based on the overcurrent protection device of the tap conductors, not the main conductors. To summarize the potential violations, firstly, the main concern was that the tap conductors might not meet the 1/3 ampacity requirement. Based on typical 60 degrees Celsius ampacity ratings for number 6 AWG copper conductors, the 55 amp rating would violate the tap rule since the main's overcurrent protection requires a 66.67 amp rated conductor. However, if the number 6 AWG conductors have a 75 degrees Celsius rating, the 65 amp rating would still violate the 1/3 rule. And finally, if the number 6 AWG conductors have a 90 degrees Celsius rating, the 75 amp rating would satisfy the 1/3 rule. Secondly, the grounding conductor was thought to be undersized. The number 10 AWG ground is acceptable for the 30 amp overcurrent device protecting the tap, as per NEC Table 250.122. To provide a more detailed explanation, let's delve deeper into the relevant NEC sections. Article 240.21, location in a circuit, provides specific requirements for overcurrent protection. Subsections such as 240.21. E. Address tap rules. Specifically 240.21. B. 1 covers the 10-foot tap rule, 240.21. B. 2 covers the 25-foot tap rule and 240.21. B. 5 covers transformer secondary conductor tap rules. For the 25-foot tap rule, as outlined in 240.21. B. 2. Several conditions must be met. Firstly, the length of the tap conductors must not exceed 25 feet. Secondly, the ampacity of the tap conductors must not be less than 1/3 of the rating of the overcurrent device protecting the feeder or branch circuit conductors from which the tap is made. Thirdly, the tap conductors must terminate in a single circuit breaker or a single set of fuses rated not more than the ampacity of the tap conductors. Fourthly, the tap conductors must be suitably protected from physical damage and enclosed in a raceway or cable armor. Considering these requirements, the original installation seems to meet most of the conditions except for the ampacity of the number 6 AWG conductors, depending on their temperature rating. If the number 6 AWG conductors are only rated for 55 amps at 60 degrees Celsius, the 1/3 rule is violated. The grounding conductor size is determined by NEC Table 250.122, which bases the equipment grounding conductor size on the rating of the overcurrent protective device in the circuit. Since the tap is protected by a 30 amp breaker, a number 10 AWG copper grounding conductor is adequate. The concern about sizing the grounding conductor to 1/3 the ampacity of the main conductors is not applicable in this situation. To further clarify, let's consider some additional factors. The type of load connected to the 30 amp breaker is important. If the load is continuous, meaning it operates for 3 hours or more, the overcurrent device should be rated at 125% of the continuous load. This is to prevent nuisance tripping of the breaker. Also, the voltage drop in the tap conductors should be considered. Excessive voltage drop can cause equipment to malfunction or overheat. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Another aspect to consider is the environment in which the tap conductors are installed. If the ambient temperature is high, the ampacity of the conductors may need to be deaerated to prevent overheating. NEC Table 310.15 addresses ampacity correction factors for ambient temperatures. In summary, the tap installation described is likely in violation of the NEC if the number 6 AWG conductors used in the NMB cable are rated for 60 degrees Celsius. In that case, the conductor ampacity is less than 1/3 of the rating of the overcurrent device protecting the main conductors. The grounding conductor size is adequate based on the 30 amp overcurrent device protecting the tap. It is important to consult the latest edition of the NEC and local electrical codes to ensure compliance with all applicable requirements. If the conductors have a 75 degrees Celsius or 90 degrees Celsius rating, the installation meets the minimum NEC requirements.